So looking at the same examples that we had before, we're now going to try and solve these equations. So if we took that original expression of x squared plus 4x plus 3 equals 0, and we were asked to solve it, and the question is likely to say solve by completing the square. So you would go through the process of completing the square as we did previously, and we would have got to x plus 2 all squared minus 1. That's the same as x squared plus 4x plus 3, so that must equal 0. When you have something in this form, what you can then do is we are going to add 1 to both sides. And if we do that, I get x plus 2 squared equals 1. Now I can take the square root of both sides. If I take the square root of something that is squared, they cancel each other out, so I just get x plus 2. If I take the square root of 1, I get plus or minus 1. It could be positive or negative. You will sometimes see it written with that positive and negative on top of each other, or you can just write it as a 1 and a minus 1. So those are the two values that x plus 2 can be. So to find x, we're going to subtract 2 from both sides. And so x is going to be 1 minus 2, which is minus 1, or minus 1 minus 2, which is minus 3. So the two solutions to that equation are minus 1 and minus 3. Now, one of the reasons that we often complete the square is because an equation can't be factorised. That previous one could be. But if we look at this one, this one, it can't be factorised. There's no way that we can factorise 8 squared minus 8x plus 1. But we can still find solutions. They just won't be whole numbers. So if we have x squared minus 8x plus 1 equals 0, we know, because we did it previously, that when we complete the square on that, we have x minus 4 all squared minus 15 must equal 0. So if I look at trying to solve that equation, I would add 15 to both sides. So I would have x minus 4 all squared equals 15. To then find out what x minus 4 is, I have to undo the squared bit, so I'm going to take the square root of both sides. So that gives me x minus 4, and it gives me a positive 15 or a negative 15. I have to remember both solutions. And then to find x, I'm just adding 4 onto both sides. And so x would be 15 plus 4, which is 19. Sorry, it wouldn't be 15 and minus 15 at all. See how many of you spotted that one. When I take the square root, it would be the square root of 15, or the square root of minus the square root of 15. Okay, I needed to take the square root of both sides, so it has to be square root of 15, which isn't a whole number, so we will just leave it like that. So then I have, when I add 4 on, I get 4 plus the square root of 15, or 4 minus the square root of 15. Now, if you put that on your calculator, it will give you a decimal. We're not interested in the decimal. This is what's called leaving your answer in surd form, and we have worked with surds before, so you have to leave it like that. Let's look at one more. So this one, our lovely fraction one. So if we are given x squared plus 5x minus 2 equals 0 and asked to solve it, we know that we've completed the square already, and so we've got x plus 5 over 2 all squared minus 33 over 4 equals 0. So first thing I'm going to do is to add the 33 over 4 to both sides. So that will give me x plus 5 over 2 all squared will equal 33 over 4. I then need to undo that square. To undo a square, I'm going to take the square root. So I'm going to take the square root of both sides. So when I take the square root of both sides, I'm going to have x plus 5 over 2 here, and I'm going to have plus the square root of 33 over 4, and I'm going to have minus the square root of 33 over 4. Now, if you do it on your calculator will give you a slightly different answer, and I will show you why in just a second. When you take a square root, you can take the square root of the top and the bottom, so the numerator and denominator, separately. So with this positive root 33 over 4, we can take the square root of 33. We can't do anything with it, so we leave it as root 33. But the square root of 4 we can do, and we get 2. So we can leave it as the square root of 33 on the top and just a whole number 2 on the bottom. Similarly with this one, we're going to have minus root 33 on the top, and then when we take the square root of the 4 we get 2 on the bottom. The reason that that is very pleasant is because we've now got all our fraction bits have denominators of 2. So when we subtract our 5 over 2 to find out what x is, all the fractions have a denominator of 2, so we can immediately combine them. So subtracting this is going to give me a minus 5, and then I've got a plus square root of 33 all over 2, or I've got a minus 5 minus the square root of 33 all over 2. Now, it's much harder when you've got the fractions because you've got much more to think about, but they all follow the same rule, that you move the negative number to the other side. You take the square root of both sides, remembering that you will always have 2 solutions here. There must be a positive and a negative solution. That's really critical. And then you deal with whether it's a minus or a plus to get rid of this, to get x on its own, to get your final answer.